What's up, everybody? GM. See Austin with I don't know, what do you call this? Like this,
I don't know. Rolls, middle
the
rolls,
rolls,
side rolls. I don't know. I got rolls
the drum
everywhere.
rolls.
Yeah.
Yeah, we
GM.
got Austin Griffiths here from Build Guild. We're ready to build some fun stuff over the next 2 hours, and yeah, just excited to build. Reached out to Austin a few weeks ago to set this up, and he was gracious enough to get some time to code some regenerative apps. So we have a couple prompts. We did a snapshot poll to determine what we're gonna build during this session. So definitely, I'm just gonna be here to assist. Send links. Look at the chat. Austin's gonna be leading the coding and walking us through the building of the app. But yeah, excited to have everybody here. We also got Sophie on the call too. So yeah, it should be fun. Austin, want to share some words? Introduce yourself.
Yeah, what's up? I'm Austin Griffith. I work for the Ethereum Foundation. I work for Ethereum at the Ethereum Foundation. I run a DAO called Build Guild. My job is developer education and onboarding. We're trying to get more devs on chain, building apps with users on chain. I think that's it. Hearts. Thanks for having me.
Yeah. So I guess we could get started. Maybe we could look at the snapshot poll.
You want to share that? You want me to share that? Hit me up with a link if.
Yeah, I got you. Let me get that link.
It sounded like Cookie Jar and Vault was what I picked up from a chat from you, I think. Is that right?
Yeah.
I was just looking at vaults. I've never actually built a vault myself, so this will be fun to do live, kind of troubleshooting through what the heck, how does this even work kind of stuff.
Yeah, that seems to be, yep, that's what, that one that has majority of the votes. Here's link. Is there a chat here? I guess I can send it in this chat.
I can't figure out how to get in the chat.
Okay, I'll send it to you on Telegram.
Yeah, that's the way.
There we go.
Okay, let's look at this link here. Snapshot link. Nice. 60%. How many? Oh, is that 6 voters? Okay, so we got 6 voters, and then what was this grant board?
Grant board sync and reminder.
Okay.
So that's basically that's Sophie. Sophie, want to actually share?
Yeah, actually, that was one of my ideas. Well, that was my idea. Basically, it's okay. Basically, the grant board name pending. It is a tool. It is a tool to manage grants. Well, it works more like a tool for supporting the communities and give them reminders for when there's grants and when the deadlines are coming and whatever. So yeah, something I imagined that that's something really, really simple, like just managing tool for grants.
Well, what I'm going to do today is start from scratch and show you how to build basically anything you can think of with the help of all the tools and resources in the space. So whatever we end up building, it will be more about the process than the result. So sorry, the grant board only got 4 votes and yield generating cookie jars got 6 votes. But I think we'll go with that. And that'll teach me how to use vaults, something that I've been wanting to do more of. So yeah. Should we just dive into it?
Yeah,
what should
let's
we
go.
Okay. So first of all, when you told me yield generating cookie jar, I was like, shoot, we're working on making a challenge for vaults on Speedrun Ethereum, but we don't have one yet. By the way, shill Speedrun Ethereum. If you are looking for the kinds of things that you build on chain and how to go build them, like if you already know how to deploy a contract and write some solidity, you should go to Speedrun Ethereum and do all these challenges, just because they're going to really take you through some of the important things. This new over collateralized lending challenge, the prediction market challenge, the stablecoin challenge. There's a lot of important things there once you get into the code to really learn. But we don't have a vault challenge, and that's probably like in the works. So I was asking ChatGPT how I would go about having a vault. And this is usually where it starts, right? Like dinking around, asking questions with ChatGPT. But ChatGPT was totally dumb and told me that I would like have to burn shares of the address this, which is like the contract. So I was like, okay, let's set up an example. Alice has 1,000, Bob has 1,000. They've each deposited some ETH, and then like it burns 500 that's owned by the contract, which doesn't make sense because it's like the contract doesn't own any. Alice has 1,000 and Bob has 1,000. So basically ChatGPT was like totally hallucinating and leading me in the wrong direction. And it would have been like really bad if I would have tried to implement something like this, because this line would revert always and we would be stuck. So just like starting with a word of warning here that like GPT is better at optimistically hallucinating things than being critical and thinking about things. So be careful. Even though this is a great resource to like bounce things off of, you really have to be careful with, you know, totally trusting the AI. So what actually will happen here, and I then went to Solidity by example and went to their vault example and kind of looked at, okay, this is like and I kind of knew this before, this is like a standardized way to deposit and withdraw. And then what's going to happen there is that some owner is then able to, you know, control this money. So like we'll put some ETH into this contract and we'll have some kind of like unit of account, either like some ERC20 that's minted back to us that has some shares or just some like balance in the contract. And then that ETH will sit in that vault at first. But what can happen there is, since it's like a standardized interface, lots of different software can interface with a vault, and then the vault can interface with lots of different pieces of DeFi, but you have this nice standardized way of doing a deposit and withdraw, and that creates this nice layer of composability. If you know, work with a standard, then it's going to work with a whole bunch of other things. And so once the money gets here, then there's like the second step of doing something interesting with the money. Maybe we'll like stake it and earn some like staked ETH rewards on it. But that's like kind of up to the vault owner to do. So just like kind of hitting that as like the first like concept we're learning here. I went to Speedrun, or well, I learned all of this from speedrunethereum.com, but then I went to Solidity by example and I tinkered around. Maybe I even brought up like Remix Lite and tried to deploy this and put in a token contract and deployed it and tinkered around with it a little bit. But then I'm like, okay, let's implement this, or let's start implementing this. And to do that, we will jump over to Scaffold ETH. Scaffold ETH is an app building or a decentralized app building toolkit. You can go to scaffoldeth.io or Google Scaffold ETH to find it. Really like hella open source, great docs. What I'll do is copy this npx command and we'll get started. So we're going to make a vault cookie jar. Ooh, cookie jar. Okay, so the other aspect of this is like, okay, so there's a vault, people can deposit money, that money lives in there. Some vault owner can then, you know, use that money to do something in DeFi. Rewards will be earned back to the vault, and then original depositors can withdraw their funds and get some of those rewards. But it allows like thousands of people to ape into a single contract, and it keeps track of balances, and they earn some stuff and withdraw. But we haven't talked about the cookie jar thing. And so, okay, so going back here, I would be like doing a little research on how a cookie jar might work. But I've done this before, going to Build Guild, and I'm going to go to the Build Guild app, and I'm going to go to Builders, and I'm going to find Mr. D. So a few years ago, maybe even like 4 years ago, a homie Mr. D tweeted that if someone would just give him 1 ETH a month for, or maybe it was 10 ETH. If someone would just give him 10 ETH, and this was a long time ago, ETH wasn't as valuable, and it's back on the rise, but it'll be back down again tomorrow. You know how it goes. He was like, if someone would give me 10 ETH, I would quit my job and just start working for Web3. And I had seen some of his work, and I kind of liked the vibe of his design. And I was like, well, how about I give you 1 ETH a month for 10 months? And he was like, all right, I'm down. And so I deployed a smart contract for that. And let me go find that smart contract. So if I go to his profile, we can see all the stuff he's built. I'm gonna have to go to V3, go back to the old version. We're on V4 of Build Guild now, but going back to V3, we'll be able to find his stream, and then I can jump out to the smart contract. Yeah, 3 years and 147 days ago, I deployed this contract. So it's been around a while. But really the logic is here, and we'll use this logic, I think. So basically you set a cap, you set a frequency in which they can withdraw, and then some interesting mechanics happen here. A lot of times a streaming contract or a cookie jar might not start full. And some people have even seen this contract and said there's a vulnerability because it starts full. And that's actually how I want it to work. I want it to start full. I want it to have maybe 0.5 ETH in this case in it. And every 2 weeks he can withdraw and it starts full. So as soon as I deploy this contract and load it up with some ETH, he can immediately withdraw 0.5 ETH. And then it's basically like a battery. Okay, and then the second weird thing about this is once it's full, it basically pauses. So the battery, if you think about it, can only ever be full at 0.5 ETH. And as people withdraw, it goes down. And as time goes on, it leads up to this cap, and then it stops at the cap again. So there's kind of like this capped amount that you can withdraw, and that charges back up over time and starts full. And I really like this model because it's like, I trust you, here's some money, withdraw from it, but it's still rate limited. And also you can disappear for a while. Like you can be around and you can be withdrawing from it, but then if you peace out for like 3 months and go do something else, that's fine too. Like we're in Web3, we're working in a weird industry. It's okay if you disappear. And your stream will be waiting for you when you get back, but it's not going to be loaded up with 3 months worth of stream. It's still going to be at that like capped amount, and you'll be able to withdraw from it again. So this is my cookie jar version. It's old, but it works great, and I've redeployed this contract way too many times to mainnet Ethereum. I've spent probably way too much gas on this kind of stuff, but I'll use this. So we've got like some kind of example vault from Solidity by example. We've got an example cookie jar like mechanism. We don't have any strategies yet. We'll probably get to that third, but we kind of have the two things we want to mash together here today. So now let's get started building. We've done our research of like how we might go about doing this. So I'm going to go to scaffold ETH. I'm going to grab the MPX command. Let me pause real quick to make sure there's not like some other questions that I've missed here. I'm going to grab hard hat or foundry. You kind of have the choice here. I'm just going to do hard hat because the developers of scaffold ETH use hard hat more. And I would say that like if you're cracked and you know what you're doing, you should always select foundry here. If you're a builder but not a cracked developer like I am, you should just select hard hat because it's a little easier and nicer for deploying and stuff. Okay, let me pause there and see like, is there anything I'm missing here? Have I correctly posed our challenge?
Yeah, I think it definitely is a remix on the cookie jar, like which I appreciate. I do wonder because I'm not sure who had the prompt. Matt actually had the prompt, who's in the stream room. Because I'm not sure if the goal was to build off of this current cookie jar contract, or in essence build something completely new. So I'm not sure what his intent was behind the prompt, but maybe Matt, you could chime in real quick.
Or just like the mechanics of the cookie jar. Like, do you not want it to start full? Do you want it to be capped differently? Like, basically, we're going to start from scratch here, and I'm going to create a brand new contract. But like, what do you want the mechanics to be?
Mm-hmm. Matt, if you could chime in, given to your prompt, that'd be great.
Yeah, I didn't have anything super specific in mind, to be honest with you. Whatever functionally works the best is cool with me. I'm happy to defer to Austin.
Cool. Yeah. So we're just going to make something where we load up some ETH. We specify some people that can withdraw from the cookie jar. They can withdraw at some rate limit, which is maybe just like $100 a week. It's probably not going to be like 0.5 ETH. And 0.5 ETH was like, I'm paying you to do a job. This is more like you need some extra money for deploying, or I don't even know what else, like just some extra scratch here and there. And I'm going to put it into a vault where it's going to be invested, perhaps like staked ETH. And then you can withdraw from that at $100 a week, kind of pulling off maybe even just like the yield that I'm earning, which would be nice, right? So let's go with that. Okay, so I've got Scaffold ETH here. I've installed it. I've CD'd in. We'll have to run a couple commands. We'll do yarn chain, which will bring up our local blockchain. I'm going to do yarn start in another terminal, which will bring up our front end. And then we'll yarn deploy some example contract to our local chain. And let's just get a look at all of that. And also pull up cursor because we're going to be doing some vibe coding here. I'm not going to write a lot of code. Yo, what's up? Some people have joined here. Got to run a tighter ship around here, man. You just got some randos coming in. Okay. So we've got our environment up. Basically, we have Scaffold ETH here. We've got our example contract here. We've deployed it to our chain. Now I'm going to go to debug contracts, and this is kind of the nice stuff with Scaffold ETH is we can kind of tinker around and get our footing and figure out just exactly what we want to build. We're also going to have burner wallets in the top right here. This allows us to kind of click, make quick transactions without having to deal with browser extension wallets and chain IDs and stuff like that. Looks like it's loading up for the first time, so it's got to do some compiling. We're compiling. Here we go. Let's go. So this contract is basic. This is what Scaffold ETH comes with. It's like a greeter contract. There's some greeting that you set. I guess we increment a counter. This is an interesting little thing. If you send in money, it sets the premium flag to true. This is kind of a fun little thing to debug. Wow, this is taking forever, bro. Let's go. Okay, here's our debug. This is what you see. You can see the contract address here. We're on hard hat. We don't have any money yet. We've got a burner wallet. Let me just redeploy the contract just to show. Oh, whoops, not rest. We'll rest when we're done. We want to reset. So what we'll see here is this contract hot reload. We just deployed a new contract, so we get a new front end, right? And maybe the total counter is at 0. Let's start the total counter at 42 for some reason, and let's redeploy, just showing that we're getting this nice feedback loop here where we'll get a new contract here, and the total counter will now be 42 for some reason. And if I say hello world, this is going to fail. It's going to say we don't have any gas, right? You got to go to the faucet up in the top right, grab some gas. But now you're set up, you're ready to tinker. You've got gas, you've got a contract deployed, you've got your code over here. You can say hello world and it updates the greeting, and now the counter is 43. So remembering this interesting line here where we had, premium equals true if you send in some money. Let's send in like 0.001. First kind of learning moment, if this is the first time you've tinkered with Solidity, is that we don't do any decimals. The EVM does not fuck around with decimals. It wants to be simple. So the more simple the EVM is, the more decentralized the apps can be. So what we do is some really weird stuff where we multiply by 10 to the 18 any decimal on the way in. So this is what 0.0001 ETH looks like. And we'll hit send. And now we've done that. We've basically paid money into the contract. There's $3.61 locked up in our contract. And since we paid some money to say hello world, now the premium flag is true. Okay, so we've kind of tested our smart contract. We've tinkered around. This is the basic intro to Scaffold ETH. Let's start dinking around with a vault contract. So I could just grab that one over on Solidity by example. Let's see what it well, this one has like an immutable token. I don't even know if I want to give people a token. Like basically they could invest in the vault, and then they'll have a token, and then they could trade that token to other people. I really don't know if I even want to do this. I think instead of having a token, let's do this. Let's copy this. And let's go back over here and let's start vibe coding. We've got your contract fed into cursor here. Let me zoom in so we can see. Oh, I guess that's, let me zoom in so we can see it really big. I've got Claude 4. So I'm going to say, like, here is an example vault. Plah. Oops. And I'm going to say something like, this one uses a token. Instead, let's just keep track of balances right in the contract and not have a token. Adjust your contract to be a vault contract. Okay, something like that. We're vibe coding. Let's see what happens. I've given it an example vault. I'm guessing it kind of understands what vaults are. You're going to have this standardized deposit function, standardized withdraw function. There's like this mint where it's minting these tokens. Really, it should just keep track of your balance instead of, there we go. It's looking nice. This is looking nice. Let's see what it does. Let's then get this vault contract in here. Let's deposit some funds. Let's tinker around, see if it looks like we want it to look. All right, I'm just going to accept all and deploy, YOLO this thing, and let's go tinker around. Uh-oh. We had an error that is probably something to do with...
I think it's still building. It's still doing something.
Oh, yeah. Oh, it's actually calling your contract. So I think, oh, yeah, it probably fixed it. Basically, the deploy script still has some junk in it from before, and now maybe it's fixed. Yes, okay, it's fixed now. So Vault is deployed. The owner is F39. I actually want to make the owner, oh, wait, stop this. Don't do that. Did it already do this? It may have like started up a new chain or something. Sometimes it goes nuts. Let's say make the owner of the vault atg.eth. So this is really cool. What's going on here is I have an ENS MCP server. So there's an MCP server. If you just Google ENS MCP, you're going to get this this nice server. You can give your agent some extra abilities by adding MCP servers to it. And this is a nice little ability because it's able to look up ENS addresses. So when I say atg.eth, it's going to go call this resolve name. It's going to get an address back, and it's going to put that address in as the owner. Really smart little thing it's doing here, where now hopefully I am the owner of this. And let's go redeploy and see what happens. Cool. Yep. And now the owner is me, and I recognize this, but let's go triple check. If we go to address vision and we paste this address in, it is austingriffith.eth. It is atg.eth. We are good. And there we go. Now I'm the owner of the contract. Get exchange rate. Okay, this exchange rate is interesting. Let's go start looking at this contract. How does this contract work? Let's go dink around with it and make sure we understand. So this was the deploy. This is where it figured out the vault owner. It passes it in as a deploy argument. We'll probably never look at that again. Here is the contract. So the contract is going to be super simple. It's going to meet with this vault standard. It's going to use this vault standard. There's some owner. There's a total supply that's tracked. Then we're tracking balances of each person as they deposit or withdraw. The constructor takes in the owner. There's a nice modifier for who is the owner. You're able to mint, and that's a private function, right? And what that does is bring the total supply up and then give it to the person. You're able to burn, which takes the total supply down. Okay, now let's look at what happens. When someone deposits, it makes sure that it's a payable function, so people send in ETH. It makes sure that you put in some ETH. It gives us a nice console log for now. We'll probably take that out when we go to production. If it's the first mint, it sets the total supply to whatever the value is. If it's not the first mint, it's going to have to do this interesting thing here where it's figuring out the exchange rate, basically, where it's looking at the total supply times the amount that you put in divided by the balance before. And what that gives us is how many shares you get. So let's say I put in an ETH, you put in an ETH. We're each going to have like 1,000 shares or something like that. And that's what we want to test. In fact, what we really want to test is the second mechanic of if someone withdraws from the cookie jar, our shares should stay the same, but the overall amount of ETH that those shares control will go down. So then if someone else comes in and puts in another ETH, they'll actually have more shares. And I want to test all of that before we move on to the next thing. But let's just like, here's this exchange rate where it's looking at your balance divided by the total supply. So what's going to happen is as this leaks, this total supply is going to go down, right? So the exchange rate would go up. Okay, let's deploy this one more time. You can deploy this as many times as you want. You're on localhost. It's free, cheap, private, all here just for you to tinker. Now let's say I got this dude over here, right? This is 05. This is my burner wallet. If I go look at my balance so far, it's 0, right? I've got maybe $3,600. So maybe we want to deposit some. Let's try that. Let's deposit 0.01 ETH. Now, of course, in the front end, I want this to be USD. I do not want it to be an ETH. I don't even want to do this like ETH versus way junk. All of this will be handled by the front end, and we'll get to that in a moment. But at first, well, let's make sure, like maybe, okay, it hasn't edited the front end at all. And that's good. We don't want to yet. We just want to tinker around with the contract. So we got to talk in ETH. We've got to click this button. This is a very developer-y interface. A lot of people who one-shot apps totally skip this phase because they don't even want to like really get into the contract and understand it. But we need to get into the contract and understand it a little bit. So we've minted some and the supply goes up. So now if we check this dude's balance, we should see that he's got some. And then if he deposits some more, we should see that that balance goes up. And what's that exchange rate, right? The exchange rate is there. And what we would want to see is if the balance of the contract went down, what we would have is some other function in here called leak. Maybe we could just add that in for now. Function leak. Let's give it an amount, right? It'll leak some amount of money. Only the owner can do it. That's exactly what I want to do. Good job. Yes. Basically, it's going to leak money to the owner, which is kind of funny. But let's go ahead and deploy that. And of course, this will be the streaming contract. So this will be rate limited, and more things will happen. But what I want to see is I deposit 0.0 or 0.1. Okay, it's in there. Of course, we've got a fresh contract here, so we're seeing fresh numbers. My balance should be that number exactly, but what I want to do is leak 0.001 out of it, okay? And then what we want to see is that, oh, we're not the owner. Okay, so hold on now. We got to connect a different wallet. I have to use MetaMask because I'm on localhost right now. But normally I would be using Rainbow. Okay, so what I want to do is leak 0.001. So a small cut of this ETH I want to leak out, and I want to make sure that the exchange rate goes up when that happens. And that means that, oh, whoops, it need to hit that button. Now we leak. Yeah, okay. I've reviewed the alert. Just give me the button. Oh man, I hate MetaMask so much. I hate it from the depths of my soul. What in the hell? Okay. Here's what we're gonna do. We're gonna go completely around MetaMask because it is garbage, and we are going to create a burner wallet on localhost. So we're gonna have a second burner wallet, and this burner wallet will be our owner. Okay, so let's copy that address. Let's go back to that deposit function I said, or that deploy script I said we would never look at again. And instead of me being the owner, we're going to set this 76 guy. Okay, and we'll redeploy everything here. Where's that deploy? Boop, boop, boop. There we go. And probably I'm doing something wrong with MetaMask. I blame MetaMask for a lot of things, and at least half the time it's user error. But I'm so tired of problems with MetaMask. Okay, so what we're going to have is two different. Yeah, no, I use Rainbow usually. Rainbow's great in production, but Rabby works great on localhost too. Yeah, Rabby gang, shout out. Yeah, nice. Oh wait, shoot. So there was some questions in here. I'm sorry that I missed that. I think I saw a question. Let me just quickly scan. There was a question about the date and time. Is there any issues around checking date and time from the contract, or is this no issue? Yeah, so the only issue you could run into is that it could be off by like 15 seconds, because that's the wiggle room you have as each block is being minted. I think, like, back in the day, I think that was an issue. I don't know if it is anymore. Basically, it could be off by 15 seconds, but for these purposes here, where we're talking about, a week in terms of the time span, an extra 15 seconds here or there is, a rounding error of a rounding error. So we're not too worried about that. All right. Let's see. Any other questions here?
I think that's it for now.
Okay.
Yeah.
I'll keep a
But
better.
definitely
I'll
chat.
keep a. Yeah.
If you have any questions, definitely
Yeah.
share in the chat.
Yeah. Okay. So what we're going to do now is we're going to redeploy our contract, this time without using any MetaMask addresses. So we have two burner wallets. We've got this guy who's the owner in incognito. We'll see in the debug contract owner, you can kind of match the blocky visually, right? Give this dude some ETH. Then we've got the user. We're going to disconnect that. We'll call this guy the user. And we're going to even create a third account, a third thing. Let me bring back this, and let me get like a new one of those. Nope. Yeah, sure. No, actually, I didn't want that. Shoot. I want the other dude, this dude. And let's do another incognito. Okay. And let's do localhost 3000, right? I can't believe I'm typing. Why is that not already? Okay, so now we have 3 characters. I'm going to call this like watermelon user. This is normal user. Doesn't that kind of look like a watermelon candy? I don't know. And then there's like green, like admin. So we have the owner, and then we have like player 1 and player 2. Okay. And all of them are going to do some interesting things here. So what I want to do is I want, first of all, player 1 to deposit 0.5 ETH. Okay. And then I want to copy their address and look at their balance, and it should be that, right? Now I'm going to use the owner, and I'm going to leak a small amount of this. Okay. And that will send that money to the owner. So the owner actually just made some money there. But what I wanted to see is that exchange rate. I thought it was going to go up. It went down. Maybe that's right. I'm not great at the maths. I'm just great at tinkering. So then what I want to do is have this dude also deposit. So now here's what's happening. The first player deposited, and then some of that money was withdrawn. And then another player is going to deposit, and I think the exchange rate is going to change because of that. And if this second player deposits the same amount, he should end up with a different amount of shares. And that's, I think, the important part here. Oh, wait, why is the total supply not the same? Oh, okay, we just got to reload. Okay, we needed to reload. Oh, no, owner's balance. Two's balance, it should be different. It should be a little bit more, and that's what we want to see. So the reason is player 1 put in half an ETH. The owner leaked some of that. So now there's actually less ETH in the contract. Player 2 came along and put in another half ETH. So if we think about this, player 2's contribution is actually bigger than player 1's because some of player 1's ETH has leaked. And that's how we want it to work. We basically want the vault to be earning something, withdraw people to be able to withdraw, and the contract leaks. And then when someone else new comes in, there's like an exchange rate that's based on what the supply is versus what the ETH is, or how many shares there are versus how much ETH there is. So that's what I wanted to see. I wanted to see that all of that worked, and it did work. The other thing I might check is like, can this dude withdraw correctly? So let's do that. Let's see his. Let's do it with this dude. It's easier. This dude has kind of a half ETH of a balance, or 0.5 of a balance. So let's make sure they can withdraw like 0.25 or something like that. And when, okay, let's think about this. Let's even make this even simpler, since we've already tested one thing. Let's make this really simple. Let's redeploy. What I want to see is it starts fresh. Okay, we're gonna deposit. Let's give this dude some more money. We're gonna deposit some, maybe just 1 ETH. Okay, we deposit. Okay, then with the owner, we're gonna leak again 0.1 ETH. Okay, so 10% of the money leaks out. Okay, that's good. That's what we want. Now, when this guy goes to withdraw, so he still has, if we look at his balance, he still has 1, which is not 1 ETH. It's like 1 ETH worth at the time that he deposited it. Basically, shares are minted at some exchange rate. So what's happening here is when he withdraws his 1, he's not going to get a full 1 out of it, right? He's going to withdraw 1, which represents his cut of the shares, which is actually 100%. What we want to see here is basically all the money come out of the contract. It did. So he got back 0.9 ETH, even though he put in 1 ETH, because what he's minting, what he's getting, what his balance is here is his cut of the ETH. So multiple people can deposit in. They have some shares of that ETH, and that ETH can leak to some other person who can withdraw, which is great. It's all working. I like the way the deposit and withdraw is working. The vault is basically doing what the vault needs to do. Now that leak function we've written, let's go look at that. Let me pause. Any questions? We're kind of doing some strange stuff. Hopefully I'm not. Boo, boo, boo. Oh, wait. Yeah, hold on. Let me shill. Are we live? Oh, yeah, we're live. That is so dope. I love that that is right in the, I got to shill. Sorry, go ahead.
Oh, no, go for it, Austin.
Okay, cool. Yeah. No, I'm just retweeting this real quick.
Mm-hmm.
Catch me vibe coding. What are we vibe coding? A cookie jar.
Cookie jar yield.
Vault smart contract where the yield is given out as cookies to the homies. I don't know. That's what we're going with. And then I'm going to go with robot emoji, stars emoji, helicopter emoji. Yeah, send it. Boom. Okay, cool. All right, now let's see. We've got our withdraw and our deposit. We've kind of like hacked in a little leak function to make sure that the ETH can leak out and the exchange rate still works. We played around with it. Player 1 deposits, some leaks out. Player 2 deposits, and player 2 actually has more shares because they contributed more relative to player 1, who has had their shares leaked on a little bit. But this leak function is just like this only owner heavy. Owner just like steals the money and takes it. Now, the owner will eventually be able to invest the money. So pretty soon there's going to be some invest function here where the owner probably swaps the ETH to something else. And then when you withdraw, you get your shares that swap back. But before we even do the only owner investment function, we want to figure out this leak function. And instead of leak, we're going to do some kind of withdraw. And we're going to go back to that contract that I had here, this simple stream. And what we want to do is basically stream to someone. So I'm going to go back to GPT. I'm going to open up a new chat, kind of clean the context out, give it the contract, and say, here is a cool withdraw streaming contract I built back in the day. It doesn't need any of this context, but here we go. I'd like to update our leak function here. Actually, no leak function. I'd like to add a new grab cookie function that allows. Okay, let's see. Who do we want to be the withdrawer? Right? We need like some address. I'm just going to say like punk.Austin Griffith, actually I'm gonna say t.atg.eth. It's just like a little burner wallet I have here, just coming up with this person to withdraw up to 0.1 ETH per week. Actually, let's do 0.01, like a small amount, right? It's a cookie. It's not ETH per week. It starts full and pauses full, just like the stream contract I've included. Okay, I don't know if this is gonna figure this out. This is kind of a stretch. Let's see if Claude can figure this out. So it's got to do some ENS lookup. It's got to use the. I love the streaming withdrawal concept. You're so right. It did the lookup. So now we've got the address. There we go. Now we're getting some code written here. Let's see what this looks like. So the cookie address would be the person who can withdraw. I bet if we go look this up on Address Vision, we see that this is Punk. Oh, what's up? What's up? Yeah, there's t.atg there. Was someone asking a question there, or?
No, that's a.
Okay. Yeah. So this is the kind of our beneficiary. This dude right here will be able to withdraw cookies. He'll be able to grab a cookie. Let's go back and look at that contract again. The cookie cap is 0.01 Ether. The cookie frequency is 1 week. And then we keep track of the last time they withdrew. And there's a cookie grab. Nice. And then we set the cookie last on deploy. Very nice. Okay, so what we want here is we're going to pull this leak function out. Eventually, there will be like an only owner invest function. But what we're really looking at, nice, cookie balance. This is really good. Grab cookie. Let's go look at this. So what happens when someone grabs a cookie? We make sure that they are the cookie address. And maybe we could even have this be like an array. And you like, you know, if their address is in the array, we'll keep track of a balance here. Yeah. Okay. So they have to grab some cookies. We look at what their balance is and make sure that they're not grabbing too much, make sure that we actually have that much in the contract, and then we update their last grabbed. And yeah, that looks good. Okay, so real quick though, to test this, we're not gonna want to have a week-long frequency. Like we wanna test this thing out. Let's say that they can grab this every, I don't know, maybe like 130, no, that's a weird number, 120 seconds, right? So oh, nice, thank you. Thank you for doing that quick math for me. So every 2 minutes, you can withdraw, the whoever we have as the beneficiary, maybe it's an array of folks, but a set of people are allowed to withdraw some cookies. And in this case, it's a single address for now, but we can update that every 2 minutes. Every 2 minutes, you can get 0.01 ETH out of it. And let's go ahead and deploy and see how it works. Sweet. Okay, so I'm going to need to actually have this dude as a player. So I'm going to disconnect and go ahead and connect with Wallet Connect. And then I've got my Punk wallet here set up. If you do lots of quick, whoa, come here. If you do lots of quick transactions and you need burner wallets, I have this Punk wallet that I'm going to be using, punkwallet.io. There we go. There's the guy. You kind of recognize him by the headband. See that headband? Yeah. That's this dude here, right? The dude with the headband. So I've got the keys on this device. I'm going to put it on, well, it would be on localhost, wouldn't it? I wonder how that's going to work. This may not work right now. Actually, yes. Let's actually, never mind. Let's bring the burner wallet back. Let's not mess with any wallets until we go to production. We'll put this on an L2 or maybe even mainnet in a little bit. Yeah, maybe we start with L2 and then we can use real wallets, and then maybe we put it on mainnet if we have enough time. But let's make this watermelon dude the cookie address. So we'll put this in here and we'll comment this. Like we want to like leave this original code here, comment this out. There we go. Okay. So now it is, oh, I bet there's a semicolon missing at the end there. Yes, please add that. Okay. So we've kind of changed who the cookie address is, who can withdraw a cookie, and we've changed the frequency, but we commented out the values. So it's going to be easy to go to production once we do this, but we've kind of got our burner wallets substituted in there. Okay. So now we've got cookie address is our watermelon looking dude, and cookie cap is 0.01 ETH, and the frequency is 120 seconds. So we've already tested our deposit functionality. So let's not even worry about that. Let's put an ETH in. We should see that the total supply goes up. We should see that the balance of the contract is now 3,613. And then what we want to do is come in as our beneficiary, our cookie address, and let's grab a cookie, right? Let's grab the full cookie amount, which is 0.01. And the reason. Okay, so this is something else. I haven't even talked about this. Another piece of this is we have them, when they do the withdraw, is they say why they're withdrawing. There's a string that goes on chain. You pay and put on chain some message about what you did, what you doing, what are you doing with this cookie, right? So I'm going to say needed new tires. I don't know. Maybe I'm a driver. I'm a delivery driver, and I'm picking up. I don't know. Maybe I'm needed new tire, right? I got one tire for 0.1 ETH. Okay, needed new tire. All right, here we go. Let's submit this. There we go. So now we should see this contract. Yep, now it's at 35.77. So we withdrew some money from the contract, and that money landed in our account, and we're able to go buy a new tire. And now if I try to do that withdraw again, this should fail, right? It shouldn't let me withdraw. Not enough cookies in the jar. What a nice error message that is. Basically, what we're doing is we're waiting for this frequency to come back up. There's a cookie balance. Let's go look at our cookie balance. Let's see, it's a read function. Oh, cookie balance is 0, right? And this is a weird thing, but you have to trigger, since we're on localhost, there's nothing triggering transactions. So the time is really weird, but there we go. We see that. And then if I trigger that again, and then I go back here, the cookie balance should be slowly going up. Yes, it is. Right? Every time I make a new transaction, that timestamp is increasing, and therefore our cookie balance is going up. When someone was asking about timestamps earlier, and I said, no, there's no issues. Actually, there is a little bit of an issue when you're on localhost because no one's making transactions on your local blockchain. So the timestamp is basically the last transaction made. So if we just sit here and do nothing, this dude's balance is actually not updating, and we can read all we want and it stays the same, but you actually have to go trigger a transaction to come back here to see your cookie balance go up. So just a little warning when we're on localhost. This is why I like to go to L2s quickly. And I think we'll go to an L2 like basically now once we see that all this is working, and we'll put it out on Base or something, and we'll make sure everything works with live wallets with real money. And then we can kind of continue to mainnet or wherever we want to go. Basically, we want to put this vault on a network where it can do something, right? It needs to be able to invest in some DeFi. Maybe we'll put it on Arbitrum because Arbitrum has more liquidity. But for now, we can just put it on any live network and go use some real wallets. I could even fork the networks locally. Instead of having a local blockchain, I could do a Yarn fork and fork mainnet or Base or whatever.
I think Cell would be a great option.
Okay, yeah, let's deploy to Cello. Let's go. I think I did a vibe code with Sophia the other day, so I still have a little Cello in my wallet, so I should be able to cover the costs. So let's go to Cello. I would say that we're actually ready to do that. I think that the cookie works, the deposit works. We kind of tested the leaking, and the leaking seemed to work. The only thing that our contract doesn't have is some kind of investment strategy. Yeah, right now, basically what you're doing is just like putting ETH into the contract and letting people withdraw as cookies, and then you can withdraw your ETH if you want, but we're keeping like a unit of account for what shares of that ETH. Like lots of people could YOLO their ETH in, and our cookie withdrawer could withdraw from it, and our shares would adjust to that. So probably the one thing, is there DeFi is there like staked ETH on Cello? Let's start doing some research.
Maybe Bertrand, you could chime in here. He's a active builder in the Celo ecosystem.
Yes, there is official AV on Celo.
There's Aave on Celo. Okay. Okay. So
both AV and Uniswap are officially supported.
okay. Let's actually just look at Uniswap then. There's probably so I love Uniswap v2. I think v3 and v4 are like stupid complex, and unless you really need to get in and do some stupid smart stuff, you should just use Uniswap v2 when you're building things. Now, there's lacking liquidity and a lot of reasons why you wouldn't do that at scale. But if there's v2 on Celo, I would love to use it. But what we're looking, go ahead.
There is no v2, but there is liquid staking maybe.
Okay. Okay.
And
let's just go.
Would be easier because you are
let's go to
having
Celo.
the native token.
Okay, I do have some. I have 0.9 of the native token. I want to actually keep that around, but we're gonna be doing this in very small amounts. Now, is there? Yeah, what could we go to here that would be like an actual strategy? Is there? You said they're staked.
If you want Uniswap v2 clone, there is Ubiswap.
Ubiswap?
Yeah, would have the Uniswap v2 interface.
Oh,
for the official Uniswap, it's only.
Okay, so there's unofficial Uniswap on Celo called
it was
Ubiswap.
before the Uniswap support.
Is this real? Is this real stake Celo? Can I copy this contract address? How about that?
Yeah,
How about,
if it's listed there.
Yeah. Okay. So let's just like let's try this at like 0.001 of my Celo for some staked Celo. Dang, not okay. Let's do this swap and figure out how it does the swap. So first thing I'm gonna do. Oh damn, switch networks in my wallet.
Yeah.
Okay. Okay, yeah, at this point, no, I still have to use MetaMask because it probably doesn't have... Wait, this doesn't automatically switch me to Celo? Bro, the Uniswap interface doesn't automatically switch you to Celo? Oh my gosh, Uniswap, what the hell are you doing? It's 2025, bro. Oh, that hurts, man. That hurt. Like the app that we're about to deploy with freaking Scaffold ETH built, yeah, it's gonna automatically switch us to Celo, but I have to go do this manually like a peasant. Oh, okay. It's okay. It's all gonna be okay. All right, here we go. Now, can I do this? Let's see what this does. I don't know, man. Oh, it's Rainbow. Okay, this is Rainbow's fault, not MetaMask's fault. And Rainbow doesn't have Celo. Let's connect our MetaMask, actually. Good job, MetaMask. Hearts, MetaMask. I'm glad that you can still be around to work. Okay, now, will this actually switch? Okay, wait. Let's go back. I think this was user error. Let's find out. Let's put this on mainnet. Oh, look, Solana is finally down at the bottom. Okay, now we're connected with our MetaMask. We're on mainnet. Now this should automatically switch me over to Celo, and I should quick confirm. Yes, it did. Good job, MetaMask. You did exactly what you needed to do. You switched me over to Celo. I was on Rainbow, which does not work very well for edge case EVM networks, and there we go. Everything is working fine. MetaMask is just right. It's doing everything it needs to do. That was 100% user error. I apologize. All right. We now have staked some Celo. Now, what I want to do is go back to address vision, to atg.eth, and go look at what just happened there. Ooh, we need Celo. Celo block explorer. What is it? Celo chain. It's Celo scan. Of course it's Celo scan. And then let's look up atg.eth. Okay. Now let's go look at that transaction. What I want to do is like what just happened when we did that stake, because that's basically what we want our thing to do. It went through the Uniswap universal router. Okay. Which is that address. Okay. Nice. Universal v12. Okay, so this is going to be the hardest part. Like getting the Uniswap stuff to happen in the contract through the universal router by just prompting it is going to be hard. So let's keep this in our back pocket and say it would be great when the ETH comes in, if it becomes staked ETH, and when the ETH comes out, it becomes an ETH again. And anybody who's investing into this vault is basically staking on Celo, and the cookies that you're withdrawing actually come out as ETH, but everything that's staked in the contract is staked. That would be great. But for now, we're just going to have it be ETH in the contract, and we're going to fight Uniswap and get the contract to work on the DeFi side of things once we know that the vault deposit and withdraw works and the cookie works out on Celo. So time to deploy our contract to Celo. Let's make one change here where we want to now actually use the real dude's cookie address, and we'll keep the frequency though, so we can do multiple withdrawals on Celo. And anything else, I think we're good. Okay, so we can actually
lower the cookie cap, maybe, if you want.
What's that?
The cookie cap, lower the cookie cap.
Oh, lower. That is a great point. Like to 0.0 ETH or something like that. So then we don't have to put so much money. That's a great idea. Thank you for that. Okay. We don't have to use our local blockchain anymore. We can actually just kill that local blockchain off. And what we'll do now is start talking to Celo for everything. So what we want to do is yarn deploy. Just like the deploy was working here to our local chain, now we'll do network -- network Celo. Okay. And it's going to tell us we don't have a deployer account and we need to generate one. And what this does is keep this nice encapsulated, encrypted deployer account just for this project. How much is it going to cost me to deploy a contract to Celo? We need to load this guy up with a little bit of Celo.
Yeah, very low.
Very low. Okay, that's what I like to hear. All right, let's give this guy like, well, I don't know what the exchange. Oh, well, let's find out. What is $1 in Celo? Okay, we're already dealing in pennies. We're going to deal in fractions of a penny. Let's give this guy a penny and hope that is enough. A penny of Celo for you, sir.
Should be enough.
Should be enough. Okay.
Let's
I
see.
only have 70 cents. Sophia did
I
not
could
make
say
me
more.
rich. Okay, so now our deployer account has a penny of Celo. We'll do a yarn deploy -- network Celo. We will enter our terrible password. I'm doing all this work to encrypt it and then not using a very strong password, which is dumb, but you at home should definitely do it for real. Okay, cool. So our contract is deployed to Celo, but you'll notice when we go to our front end, it's like, I can't even find the contract. There's no chain hard hat. You just killed the hard hat chain. What are we doing? And what I need to do is go to the scaffold config. So there's a config file with scaffold ETH, and that's located in this Next.js folder right here, scaffold config. And what we need to do is just update this chain. So there's one place, the one time we edit this one config file, and our whole app, every address, every link, everything in the app is now on Celo, right? So now if we go look at the front page and we connect our wallet, okay, it's going to show our balance in Celo. And if we click on our address, it's going to take us to Celo scan. So we had to just change that single variable there, and now we're on an EVM chain. So as you're deploying, as you're tinkering around with scaffold ETH, you are dangerously close to production, right? You just need to yarn deploy with a network in it, and you need to fund that generator address, and you need to change this one variable. And now our contract is out here on Celo. And if we go look at it, it's probably not going to be verified. And I'll probably need an API key to verify it. Let's see. I don't think this is going to work. I think I've tried this before on Celo. So basically what I need is an API key for Celo scan, and I could go get that. Oh, wait, it's taking some time. This may just work. Holy smokes, please just work. It would be so cool. What it's doing now is compiling my contract and sending it to Celo scan. And if you go look at the contract here, it looks like a bunch of garbage. But what they're going to do is they compile the contract, they compare the bytecode. And if everything works, and it did, that is so cool. Freaking Scaffold ETH is awesome. I love the developers building Scaffold ETH. It actually verified our contract on Celo. So now everyone can see our cookie mechanics, our vault mechanics. Everything is public. Everything's on chain. There is an owner of the contract, but there is, and we deployed all the console log. So we deployed way too much stuff to mainnet there. We should not have. Ooh, it's POAP time. The secret is, wait, can I say the secret out loud? Is that okay? Green cookie monster with dashes, green dash cookie dash monster. Go claim your POAP. Wow, 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 wow. Okay, so our contract is live. The console log stuff is still in it. We probably should have removed the console logs when we go to production. We can do that here, but it's only costing us a penny. Sorry, Merrick, for putting a bunch of junk on your chain, but we did it. Let's see here. Our contract is live. Let's go dink around with it. Let's go play around with it. Okay, so I can, let's see. I'll actually connect my real address now, and we go to our contract. And there's actually no UI yet. We really should build out some UI here. Okay, let's get this thing started on some UI. Let's see. We want the your contract, and we want the page. And you really don't have to do this. It's in the cursor rules. It knows about this stuff, but I like being really explicit about it. Create some deposit and withdraw UI. And then some cookie grab and cookie balance UI. So you need to be able to see your staked balance in the vault. And you need to be able to see your cookie balance if you are the cookie address. And you need to be able to cookie grab, okay? I'm not hopefully going to have to write any front end. What this AI is going to do is it's going to go read the cursor rules. It's probably going to go look at the Scaffold docs. It's going to learn that to talk to a contract, you use Scaffold read hook. If you uh-oh. Are we still there? Oh, it is. Whoa, full screen. If you write to your contract, you use Scaffold write. So it's going to kind of learn these hooks, and it's going to go write some React code for us. And if we go here and watch this, there's hopefully going to be some UI that shows up here that lets us stake into the vault and lets us, oh, getting some feedback there. And okay, so let's go dink around with this. First in the debug contracts, but after the UI gets created, we could use the UI. I'm guessing it's working. I don't want it to. Oh man, I don't know what it's doing. Let's make sure the deposit and withdraw works over here. So I'm going to deposit 0.01 into the contract. Oh, first let's read my balance, make sure it's 0, right? Then I deposit some. I'm going to pay real money, but a fraction of a cent. It's going to be super fast. We're going to deposit probably a couple pennies or maybe even less. Then if we do a read, we see that we have a balance. We can do a second deposit, and our balance should double, right? Let's make sure all of that works. Very nice. Our deposit is working. Let's make sure we could withdraw like 0.005 and make sure that withdraw works. Okay, pay some real money. Now our balance should go down. There we go. Our balance goes down. Okay, so the deposit and withdraw mechanics are looking great. Seems my connection had issues. I hope everybody's good. I hope everybody's still along for the ride. We're still kicking it. I'll watch the chat if there's questions. Basically, the deposit and withdraw mechanics of our smart contract are working. We are live out on Celo. We may even have some front end. Ooh, look at this beautiful vault cookie jar front end. Okay, we even have shares, right? Okay, let's see if this works now. Actually, I'd like this to be. Oh, it can't be in USD because it's unable to fetch the price. Darn it. Okay, I would love this to be in USDC. or USD, I mean, but the problem is that Scaffold ETH goes to Uniswap V2, and like you said, there's no official Uniswap V2 on Celo, so it's having a hard time figuring out what the price is. So we'll have to just work in ETH. That's okay. I think in the long run for your users, you want to display everything in USD. So if you are deploying to Celo, you probably need to do a little extra work. But look at that. We deposited with our new front end and our shares worked. Let's go ahead and withdraw some shares, make sure that works. Look at that. We're able to deposit and withdraw, and our app is working and keeping track of our shares and the exchange rate. Everything looks beautiful. Okay, now there's money in this contract. It's time to withdraw some from the cookie address, right? We need this dude, okay? Now is the time that we need to wallet connect. And I will use this dude. Oh, he doesn't have any Celo though, does he? Oh man, Celo is not even an option on the Punk wallet. Okay, we're gonna have to do something different here. I should have Celo added to the Punk wallet. Put that in my notes. I'm gonna do that. Send that off to a homie Tam and say, Tam, we need Celo in the Punk wallet. There we go. Send it. All right. Okay, so this isn't going to work. We're not able to deploy. I'm not able to connect this guy, I don't think. I think we're going to have issues. I could go through it just in case. I don't think it's going to work, though, because I don't have Celo here. I could add the Celo RPC. Ooh, yeah, let's see. No. I'm not going to go through that, but we're going to redeploy. Okay, let's get all our money out of this contract. Let's go back to here. Let's pull all of our shares out and empty the contract and say, see you later to that contract. It should go down to 0 here. There we go. Okay, so that contract is gone. It's empty. We can triple check it's empty by going into that debug tab and looking right here and seeing that it is empty. Okay, what we want to do is just change this cookie address. Sadly, I don't have Celo in the Punk wallet. So what we need to do is a couple of things. We're going to allow burner wallets in production, which you probably don't want to do normally. And then once that's there, then we'll be able to connect as our burner wallet. So Watermelon dude, that is the private key we have in local storage here. And so this dude needs some Celo. And we also need to make this dude the cookie address. Okay, so that dude's our cookie address. We're going to yarn deploy -- network Celo and yarn verify -- network Celo all in one go. After we've updated that, I hope I hit save. I should have pulled. Wait. Yeah. Let's. Oh man. Don't do that. What I want to do is make a quick change to the your contract and say, please pull out all of the console log stuff and comment the import out so we aren't putting junk on chain. I don't need to justify myself to you, but I am putting junk on chain. Okay, there we go. Hopefully that cleans out that console log stuff, because instead of putting all that console log stuff on chain, let's just put our nice clean contract on chain. Okay, there we go. We're ready in just a second. Let it rewrite the contract, and then we will YOLO it to production. Go, Claude, go. Get it done. Any questions in the chat? How we doing? Everything good? We are having fun upgrading Celo today. Cool. Heck yeah. Looks like everything is good. There's like some little kids next door having fun. I don't know if everybody could hear that, but it's pretty cool. They're like, I don't know what's going on. Okay, here we go. Accept. We're good. We're going to save this. We're going to deploy this. Yarn deploy to Celo. Yarn verify on Celo. We've still got our penny. We're still deploying on our single penny. Okay, now did we run out of money? Yes. Okay, we don't have enough money. Our account needs more money. What was that guy's account again? this dude. Nope. I can get it again by just saying yarn account. Yo, are you back? How you doing? Oh, we just need to give this dude some more cello. A penny was just the right amount. Is someone unmuting with a question? Oh, no. No. Okay, let's send this dude another. Since a penny worked, I'm going to send like 5 cents. So if we do have to do some redeploys, it'll be easy. Look at that. MetaMask is even doing a good job of getting us the dollar amount of cello, which Scaffold ETH is failing at. Shout out MetaMask for doing a good job. I shouldn't have been hating on you earlier. Okay, now we're ready to deploy. Let's see. This should work. All we've changed is we've updated the cookie jar account to be this burner wallet watermelon dude. And we need to send him some money too. Let's do that while we're sitting here. Send this dude also 0.05. Like give him a nickel also. Okay, so we got 5 cents in the deployer. We've got 5 cents in this dude's account. How much cello does that end up being? We should see that reload. There we go. Okay, so our dude has enough money for gas. Our contract is deployed and verified. The app should reload with that new contract. Here's that fresh contract. It's already verified. So beautiful. And we've got our nice front end. Let's see. The first thing we're going to do is deposit some ETH. How much do I actually have? 0.6. Let's do 0.05. Deposit. Okay, there we go. Our cello is getting deposited into our contract. We've got shares. It looks good. Okay, now what we want to do is connect to this as our cookie jar withdrawer guy, which is this guy. Uh-oh, there's no cookie. Uh-oh, I don't see any UI for the cookie jar stuff. Okay, hold on. We got to go back here. We got to talk to, oh, wait. That was like 2 prompts down, right? Yeah. I don't see any UI for the cookie grab and the cookie balance. Is that there? Or do we still need to build it? Let's see if this dude makes, oh, Claude, help us, Claude. Oh, it's saying his cookie address. Oh, okay, you hard-coded. Hold on. Yeah. Whoops. What did I do there? Yeah, I think you hard-coded the cookie address. Def, don't do that. Read the contract for who the cookie address is. Yeah. So I think what it did is it looked at whoever was the cookie address in our contract, and then it hard-coded it in the front end saying if you were this address, it's going to show it. But that is some terrible ass code, Claude. Come on now. What we want that to do is be dynamic. We want it to do a use scaffold read for who the cookie address is dynamically, and it did. And now if you connect and your address matches the cookie address, there we go. We're going to get some nice UI. There it is, cookie management. Very nice. Okay, there's available cookies. Every 2 minutes, it goes up 0.001, and we're able to withdraw. Let's make sure this guy's happy and finished. It is. Okay, here we go. Wow, this is really quick, really nice. Scaffold ETH is kicking it. Opus 4 Max. I'm using, is that Opus 4? I don't know what Opus 4 is. I'm using Claude 4 Sonnet Max. Is that Opus 4? I don't know what Opus 4 is. I don't know. Okay, but we got Claude 4 Sonnet Max. I'm paying whatever. I mean, if there's a pop-up that says pay $10 more to Cursor and Claude, I like black out and hit yes every time. This is such a powerful tool. It's built all this UI for us in one shot, except for that weird hard coding. Okay, so this dude has money, right? We've got some cello, 0.3186, and we want it to go up to 3196 minus some gas. If we withdraw, right, now we're going to the cookie jar. So, oh, wait. Is there money in the cookie jar? There may not be money in the vault yet. Let's go back to our app, reload. Yes, okay, there is money in the vault. How do we see? We should really have something in the front end. Yeah, let's go back and tell this guy, please add a balance component that shows the overall balance in ETH of the vault contract. Just so we see that in the front end, and we can see that, because this dude's going to withdraw from the contract, but he's really not sure if there's even any money in the contract, right? He's got to like go debug and go look here and say, yeah, there is 0.5, but ain't nobody got time for that. We need to have this thing just display that. And this is what's really nice about Scaffold ETH. It's got all the context. It's got both your orchestration and your contract deploying stuff and your front end. So what we should have here is a nice balance of the contract with a hot reload in just a second. Let's see. Let's see if it does it. What's it doing? Fixing linter errors. We're fixing linter errors. What do we have? We got 30 minutes left, a little more than 30 minutes. Implementing the actual DeFi in this will be hard, probably take another hour, but we'll try what we can do. We've already implemented a vault. We've tested it on local storage. Then we implemented a leak to make sure that it would work with the vault balances. Then we implemented the cookie jar. We tested it all on localhost. We put it on Celo. We tested it all there. Actually, we haven't tested cookie management. We're about to do that. We've got this dude. There we go. The vault balance is now here. And we don't have any shares, which is okay. We just see that the vault has a balance. We're not going to deposit and withdraw. We're going to take out some cookies, right? We need some cookies for some tires for some reason. All right, give us a cookie. I am hungry, sir. That's why we're withdrawing our cookie. We're withdrawing 0.001, which is our full balance for 2 minutes. It lets us eat basically one cookie every 2 minutes. Let's make sure all of that works. So what's our balance? It's 0.386. Now it's 0.387. Yeah, that. Oh, I must have spent, basically it was my gas fees. I made 0.0001 ETH on that transaction because I paid about 0.0001 to make the transaction and then got 0.001. But now look at this. Isn't this pretty? Look at it go. Look at it stream back up. Isn't that nice? With every new block on Celo, we get a new price or amount of ETH. And there is our cookie jar reloading. And if we really wanted to, we could withdraw 0.002 ETH or 0.003 ETH, but it's going to cost us like 0.001 just to do it. So we're going to let this. Oh, question there? Someone unmuted? No. Okay, cool. Have you used Claude Code yet, Celo? Hey, Austin, you're not sharing your screen anymore. Is that true? I mean, we got it. Maybe that was when we dropped. We dropped there for a second. There was a moment when things went down on the stream, but I think we're good now. Our stream is streaming along. Maybe we could tell us to only do 5 things of. I like it though. Looks good. Okay, we're letting our stream kind of refill. What if we had like a little progress bar? Wouldn't that look dope? Okay, let's do that. Let's tell it here. Let's do that while we're waiting for this. This is the available cookies. Okay, in the available cookies UI. Only use like maybe 6 decimals of precision. Also, it would be dope to have a progress bar that shows how much of the cap is available. I didn't even spell that right, but that's okay. I spelled it very wrong. And it recharges. Any questions out there? Yeah.
Also update ETH to Celo, since we deployed to Celo. The native token is Celo on Celo. And that's
okay. We're not actually, this isn't ETH, we're doing native Celo. Is that what?
It's the native token is Celo on
Got it. So while we see this as ETH, it's not actually ETH, it's Celo. Okay, exactly. So we should, I got it. Let's replace that in the front end too. Also, in the front end, we are saying ETH a lot. but I spelled a lot has a space. It doesn't matter. But actually, this is native Celo. It works just like ETH, but is native Celo. So just in the front end, replace the word ETH with Celo. Good shout. Let's have the front end do that too. And hopefully we get that nice progress bar as our progress. Oh yeah. All right. Our cookie is full again. And hopefully it replaces this with Celo in a second too. Good shout. Hopefully that'll be a good update. Nice. We'll just accept everything blindly, of course. Thank you, Claude. Thank you, Cursor. Let's go. Okay. So basically this is all working. We're able to deposit. Yo, Kevin Milwaukee, GM in the chat. Good to have you here. All right. Accept. So basically what we're building here is a cookie jar, the classic deposit withdraw, or the classic withdraw stream from Build Guild. And also it sounds like Raid Guild did a cookie jar. Build Guild, I basically paid salaries using a cookie jar method. It was more like a half ETH or a whole ETH instead of just like a cookie. But here we're doing, you deposit an ETH into a vault. It's a standard 4626 vault or 2642s. It's 4 something vault. So we have a standardized vault that can be used in DeFi, but that vault is holding some Celo, and that Celo can be streamed at 0.001 to some beneficiaries. So it allows you to lock up some Celo, and that Celo can be withdrawn in small cookie amounts, but also it is earning money in some DeFi thing. But we haven't done the earn money DeFi thing yet. We're I guess an hour and a half in this whole build. We just came up with it at the start. So we only have the vault and the cookie working, but it looks pretty good. It looks like it's working. Let's go ahead and withdraw another 0.001. And this time we're still hungry, right? And what we would do is maybe like have like something that shows, oh, let's do that. Let's do that. What I want to do is use scaffold event history. Use scaffold event history to show all of the cookie grabs with their reason, right? Wouldn't that be nice? We could read the events from the contract and it's going to, oh yeah, 1 day left to allocate your rewards in the Octant Epoch 8. Show some love to your favorites. If Build Guild is one of your favorites, definitely show some love to Build Guild. Shout out to the BG. They're doing the Build Guild. They're doing developer education and onboarding, one developer at a time. We do this with a tool, Scaffold ETH, and a curriculum, Speedrun Ethereum, and a ton of onboarding batches and a lot of hand-to-hand combat kind of things. Okay, so our cookie jar, how's it looking? How's it looking? What I want is, oh yeah, cookie jar history. No cookies have been grabbed yet. That's only because it's still writing in the event logic. That is a cute little jar right there. I love that. Like a little empty jar when there's nothing there. Very nice. Ooh, link. Can we get a link to the Octant round? I don't even know what the link is, but if someone has it, throw it in the chat and we can go to it. Okay, how are we looking here? Do we have some event history? We don't. I think maybe it's not working. I think I already withdrew once. Yeah. Boo, boo, boo. Does the contract have? Let's make sure. I have withdrawn using that function, a cookie grabbed, and that event was emitted, and that's probably spelled wrong, but I don't see anything. Okay, no cookies have been grabbed yet, and what I'm going to do is just like give it this whole double check the docs, bro. RTFM. Yeah. And then I'll give him that link, and then I'll maybe even paste that in, and maybe even I'll give him even more context and say something like that, right? And say that, give him all sorts of context. Come on, Claude, let's see if you, and it's going to be like, oh, you're absolutely right. I have found the error. I mean, I hope so. It may even be worse. It may be like I'm an idiot and missing something, but let's see what we got. Hit the scaffold ETH docs, do some reading. Yeah. Oh yeah, it's changing something. I think it was probably using the scaffold ETH history wrong or something. There we go. It's octant.app/projects. Check it out. Let's go take a quick break and look at our Epoch 8 projects. Shout out to all of them. Shout out to all the homies. DeFi Llama, Remix, Block Scout, a lot of great ones here. Solidity, Ethers.js, DAppNode, L2Beat. I mean, huge shout out to L2Beat. Anytime I'm thinking about deploying to an L2, I'm going to L2Beat and I'm saying, how decentralized are they? And then I go, oh, damn, all of the L2s still have a centralized sequencer. They're still all stage 1. What the hell? Let's go, you guys. And you know, even though this has a centralized sequencer, if one of these falls all the way down, you can still make a transaction on mainnet to get your assets. Where's Cello here? Where's Cello? Oh boy, let's go, Cello. We're counting on you. I know you just got here. I know you're kind of the new kid on the block, but since we're deploying to you, we need more. We need more here. We need more. There's too much red. Let's get you over on this page soon. Okay. What are we at here? What else do we got? Lots of good ones. Grow the pie. A lot of good ones. A lot of good ones here. I could shout out a lot of these. I feel like I've already shouted out some. There we go. There's the Build Guild. Check them out. We're doing tooling. We're doing education. We're giving small grants. Check out Build Guild. Hearts. Okay. What does our front end look like? I want to know if we have some events. Uh-oh. There was an error there, and the cookie jar is still not. Let's see. Ooh, okay. There's no, it says it's loading history. Maybe this was too much of a jump. I shouldn't have gone for it. I flew too close to the sun. We're getting some error. Yeah. Okay. Let's just give this back to this guy. I feel like this happens a lot where when it tries to read the events, it's using some old, okay, so what we can say is, what is the return value? The return value looks like this. I'm gonna paste that in too. Make sure it knows all that stuff. Yeah, it's trying to do args. I don't know what it's trying to do. This is just like, this is where when you're vibe coding, the last mile is always way hard because there's little things that it's just not doing right. And you're like, please center the freaking div. Actually, it's really good at centering a div, but it's really bad at some of this like high context stuff. Like, how do I read events from the contract using the tooling? You're right, based on the data property should contain an array of objects. Let me add more comprehensive. There we go. So what I had to do was, oh, there we go. Oh, wait, event count 0, error none. Okay, so that's still not what we want. But what I had to do is give it the return values. I only gave it like how, and what was coming back is this data events, but it's like, what is that data events? And then I had to give it some more information. And let's see if that has helped us. Damn, still nothing. Still not reading those events correctly. Come on, Scaffold ETH. What is the deal here? Why are we failing to read events? We should not be getting hung up on silly things like this. We should be working on our DeFi implementation at this point. Let's go see what it's doing. It should use right here. Let's go look at this data, okay? Whatever this is, let's do a console.log data is, yep, I have to write code manually like a peasant. Oh, it won't even let me just like put that into the, just do it. Just do it, bro. Oh, whoops, local host 3000. Data is not defined. Okay, so maybe it's like data or loading. Are we happy with that? Oh my gosh, just fix it. Just fix it. Okay. Oh, cookie grabbed event. Yeah, I'm an idiot. Of course, it's not data. It's renaming the data cookie grabbed events. Can I go back to this? Yep. Oh, was there a question there?
Are you sure about the contract name?
Ooh, no, I'm not.
Because
You're saying
your contract here.
Yeah, it's use contract info, your contract, and then down here.
Ah, yeah, okay. Every sign is.
Yeah. It's your contract, which is kind of a lazy way. I should have named this like Cookie Vault or something, and instead, prompts need a lot more context, many more actual coding. Yep, we're getting there. Okay, so let's see. What I want to do is inspect, and I want to go to the console, and I want to show data is undefined. Wow. Okay, so yeah, something is like fully wrong here with use scaffold event history, event name, from block is 0, watch is true, block data is true. Something is wrong with how scaffold ETH is reading events from Celo. I'll bet you.
Should use a block number where we deploy the contract.
Yeah, let's do that. Let's set the block number to this block where we deployed this contract here. What block was that? There we go. We're going to set the block number to this. Maybe that means it has to traverse less of the chain, and therefore it could be faster.
Yeah. And so the RPC doesn't accept to.
Oh, the RPC is just oh yes, that is it. That was it. Look at, we got data now. No, still undefined. Come on, bro. Shoot.
But
I thought there was something.
We have some.
There's something happening now. At least it's like coming back. Oh, there we go. There it is. There is the data. Okay, here we go.
So we asked too much to the RPC, and
yes. Okay, let's make sure it's not just like fully already working now that that's there now. So we're getting a runtime error because so I want to copy this and paste it. Oh my gosh, copying from the console in Chrome is all of a sudden like a real copy object. Oh yeah, that's nice. Oh frick. Just copy that text and it won't do it. It won't copy the text. Why? Let's see. What do I want to do? Well, I want to copy it. Okay, search that, and then I'll just grab that and I'll bring it back here and I'll paste it. There we go. Let's see if it deals with that. URL. Yes, that's it. Okay, so args, it now knows how to, yes, go. It's parsing args correctly. Even though I gave it in a like weird URL encoded format, it is figuring it out and it's parsing our args correctly. So yes, I would say problem number 1 is that we asked the RPC for all the events for like the last 4 million blocks. And like you said, it was like, no, I'm not doing that. Like you give me a shorter range and I'll give you some events. And then the second problem is scaffold ETH is doing something. Oh no, it's the scaffold ETH cursor file needs to include how to read events better and what the events come back as, because it was unclear on what those events we're still getting errors. What those events should look like. Is this? Yeah, I can't believe we should just like not do this. Like all I'm doing is like wanting to display the events. I hate this. This is not working. We can just not display the events here, but let's go ahead and give it like one more shot before we have to put it down. Okay, new error. Don't know how to serialize a big end. That's a different error, but hopefully you can figure it out. Oh yeah, that means it's got a value. If it's messing with big ints, then we're very close. There we go. There we go. There's the cookie. Yes, I'm hungry, sir. Okay. After freaking 30 minutes of debugging how to read events from our contract and get it to display correctly in our front end, a tiny little freaking esoteric error with some weird knowledge is finally working. This is the bad part about vibe coding. Go ahead. Sorry.
And it's still not sustainable fixed, I guess. The block number issue later on. I mean, you could.
I'm sorry, there was like clapping in my ear. What's missing still?
Should we have hard coded the block number as a
yes.
block number?
Yes, we should not.
Today, but it will not work.
It won't work tomorrow or something like that. Like the block number, we should. Okay, let's tell it. Let's say, let's not hard code the block number in the event reader. Let's look at the current block and go like minus 1,000 or something like that, you think? Yeah. And subtract 1,000 and show how fast are the block times on Cello?
5, I think.
5 seconds. Okay, yeah. Show it'll work for this demo, but it won't work for a whole day.
That's the point.
And subtract 1,000 and use that. Okay, and this is all this is going to do is now get the block number dynamically, subtract 1,000 from that, and use that as our from block. Mm-hmm. And hopefully our stuff still shows here. Ooh, maybe not. Maybe that's too well. Okay, it's still working. And let's go ahead and remove the debug stuff. And that's this stuff. Okay. Oh, dang. Current block, searching block. Maybe we need to go back more than 1,000. Let's see. Where's that 1,000? Let's accept. Maybe let's do 10,000 and see if that works. I mean, how many blocks ago was it? It wasn't more than 10,000 blocks ago. 100,000. Maybe that's too many. Maybe 1,000 is too many. What if we do 100?
Yeah, exactly. They're asking too much.
Maybe we're asking too much. Yeah. Yeah. So in the long run, you just don't use events, right? Like events are something that the nerds who are building the EVM thought would be useful, but they actually aren't. And when you need a front end, you need something better than events. And so everyone has basically an indexer that runs along with their RPC server. And all of this information, like this history, this off-chain storage is, ooh, wow, there we go. Yeah, it's not enabled for this app. Ooh, I see. We're starting to probably hit the RPC too hard. And it's like, it can give us balances. It can give us one-off things, but it's not going to read a whole bunch of blocks and give us a bunch of events.
Yeah. And you see the is get logs even query.
Yeah, you see the get logs there. Yep.
And so, yeah.
Yep.
If you have far too many blocks, that's a reply you will get.
Yep. Okay. Well, let's just accept this. It's only going back 10 blocks. Okay, that actually worked. How many can we go? 25, which is, not very long.
Yeah, but as you got your cookie, maybe more than 25 blocks ago.
Yeah, it was more, right? Okay, so let's do another cookie withdraw and see what shows up. Okay, cookie management. We've got I want to see it all work, and then we'll put this thing into production. Dang, we're not going to be able to put any DeFi into this thing. Okay, still, I am hungry. Cookie for my family. All right, let's grab some cookies. There we go. Nice burner wallet, nice quick transaction. We should see that. Oh yeah, there we go. There we go. We see it show up. There we go. The cookie jar history is showing up just for a few blocks back. We see our cookie jar recharging. Very cool UI, UX. If you use your own RPC, yep, then you can query me. Yep, exactly. What we would do here is we would run our own Cello node which probably would also need an Ethereum node also on top of it. So we run our own Ethereum node, then we run our own Celo node, then we use that as our RPC, and we also have an indexer sitting next to it that's reading all these events. There's a lot of infrastructure that goes into having a nice Web 2-like experience for Web 3, but this stuff all works really easily out of the box. It's this like, okay, we want to show the reasons why. And that's the part that is tricky. In our cookie jar system, I think it's cohorts.fun, which is our cohort system. What this does is when you deploy a stream, you can go to any of these networks and it automatically puts an indexer with it. And so you don't even read these events. Look at our cookie jar. This is so cool. Okay. We've got to go to production. We've only got 12 minutes left. I got another call to jump on. Things that are to do, okay? To do in the contract. We would love to swap to staked ETH, right? We would love to have the ETH come in, and on deposit, it swaps it to staked ETH, and then on withdraw, it swaps it back. Yep, go ahead. Or stake Celo. I'm sorry. I'm saying ETH.
Yeah, instead of swap, it can already stake, and there is a staking contract. Like a liquid staking contract.
Okay. There. Okay. So we go to the Celo.
Liquid staking. Yeah, you will find it. Stake Celo on the GitHub, and you have a UI also.
Here?
That's the first one. Yeah.
The first one.
This
okay,
one, yeah.
Cool. Yep.
This one's the GitHub.
There we go.
And then you have the Text Explorer UI and
probably that contract address right there, right? Let's go look at it. Yep. Here's a contract. Actually, there's no, that wasn't exactly it.
This is a multi-sig.
Okay. But you would go find the staked Celo address. You would find the contract on it. You would tell this guy, we need an external contract. No. You would actually import the interface into your contract for the staked Celo contract. Gosh, we could do this if we had like 20 more minutes. I should have not dinked around with freaking showing events, but I guess it really shows y'all in the chat like the issue with building Web3 with Claude. There's some edge cases, and it's good we found one because I was really shredding through everything else. It's good to see some hangups here. Let's see, is our event is already gone. Totally useless. I should have worked on the staked Celo stuff. Let's see. Can I find that staked Celo contract on Celo? Let's see if we can find the contract address. I'd love to get right to. Oh, is it? Well, maybe we see earn rewards, deposit withdraw flow. What is the address? Oh, here we go. Oh, those are validator groups. Contracts.
Deposit and withdraw flows, like you have already. Yeah, you have event for the testnet.
How does this? Ooh, you guys are using Block Scout. Oh, shout out to the Celo team for using an open source Block Explorer. Nice, very nice. Okay, so in this contract, we could probably do it. We could probably do it in time. What we want to do. Oh, this is a proxy. Darn it. We could go back here. Where's that information? This is something else. This is this. We went to contracts. Yes, there's a mint and burn function. Okay, cool. What we would do is say, let's just try it real quick. The front end will actually be really easy. I'm just going to run one command, yarn IPFS, and we'll have a front end. Ooh boy, this is this is in the final hour. Let's see what we can do. Okay, now when people deposit or withdraw or grab cookies, we want the vault to do more. We want it to stake Celo. Okay, the main net Celo staking contract is this. Okay. There we go. Is that and C688? Okay, and it has these functions. We need to call these functions. There's the mint, and there's the burn. Whenever we deposit, withdraw, or grab cookies. Okay, this is a stretch. If it can build this, I'm going to be impressed. And really, it's like one-to-one. You deposit, so then call deposit over here. You withdraw, so call withdraw over here. What it's going to hopefully do is build a little interface here to this C66 contract. And then whenever we do a deposit, it will mint some ST cello and lock up. Go ahead, were you saying something?
Yeah, because I think there was a modifier only manager on the mint and burn, so it's not available for.
Oh, okay.
Like
so
you
maybe
should
we
look
need
at
to do this from
deposit
the
and
manager.
withdraw flow. Yeah.
Okay. Deposit and withdraw flows. Call manager.
So you need to call manager deposit.
Okay.
Maybe. So yeah, it's more deposit and.
Okay, so actually we need to talk to the manager. Okay, let's grab that. Okay, let's go back and say, oops.
Huh? Oops.
Oops. Actually, we need to talk to the manager. I need to speak to your manager. That is at this address. Boom. Okay. And then let's just like copy paste, right? Whoa. Okay. I'm just going to give it all of that. We need to do a deposit / withdraw on the manager instead. And then we'll paste all of that in and we'll hit enter and we'll hope that it just figures it out. I think I'm going to accept those changes and then let it change it back. Really, this is wild. It's probably not going to work. While this is working, let's talk about going to production. So of course, our app is already on production. You can see on localhost, I'm talking to the Cello network. I'm depositing and withdrawing real money. I'm withdrawing real money in my cookie jar. It's full again. But how do you put this app out in production? There's two ways. There's Yarn Vercel. Okay, YOLO prod, and that's going to push your app to Vercel. You'll have a nice, quick Web 2 like edge requests. Okay, but if you want to be more distributed, more decentralized, we'll do Yarn IPFS. And what that's going to do is it's going to package up our front end, and it's going to deploy it to a Build Guild IPFS pinner, and then it will be pinned on IPFS, and so anyone will be able to go to our website just knowing the hash and talking to any node out on the network and saying, hey, I want to go to this website that's at this hash, and it will come back with the website. And then what we'll do is we'll host that website up on a gateway that is still centralized, yes, but using that hash, you could go to your own gateway or any gateway and look at the app. So yes. This is one of the first of many vibe coding sessions the Dev Guild will host over the coming months. Stay tuned for part 2 with cookie jar yield. Yeah, are we going to do this again? That's what we're saying. We're going to actually get some yield. I might get it done right now. We have 4 minutes left. I might just have some yield. All right, here is our app. So our app is deployed live. Let me go to eth.build and share a QR code. I love eth.build because it gives me QR codes. There's a seed phrase. Here's some more seed phrases for you. What I want is to display a QR, and I want that to be some text, and it's this text, and I want to put that in there. And there we go. Anyone can scan that QR code, and it's going to take you to our app, which is hosted, let me show you here, at community.bgipfs at this hash. So there's this great big hash, and there is our front end, and it's live, and it's on IPFS, and you can connect your wallet, and you can deposit Cello into our contract. And if you were the burner wallet that has the cookie jar access, you could withdraw cookies. 4 minutes left. Let's see. There's the QR code for our live app. And we could have done Yarn Vercel, right? Let's get that started while we're still here. Yarn Vercel YOLO prod. And I'll say yes. And then I'll say that. And I'll say yes. And that'll take a little bit longer to build and upload. Let's see how we're doing over in Cursor. How's it doing? What does it think? It created a Celo manager. Okay. I don't think it's going to work, but let's try it. Let's deploy it. I feel like it created a Celo manager. When you withdraw and deposit, let's just deploy it. Let's see what happens. Send it. Okay, yarn, deploy network Celo, verify network Celo, my deployer address. Here goes our contract. Please work. Here we go. There is our contract. Hopefully it's now verified on Celo. Our localhost app should reload. Oh no, did we? It looks like we killed the, oh no, that's not what I want. Yarn start. There we go. Get our app up. I've got to go on another call in 2 minutes. Let's see what happens when we deposit though. Let's see if it actually lets us deposit some funds. Building. Okay, here's our app. I am here. I'm going to deposit 0.01. Let's see what happens here. Moment of truth. If we deposit some funds, this is gonna fail. No way this is gonna work. Let's go look at the transaction once it goes. Okay, it went. Okay, and the vault balance is 0. That is very good, right? We don't want to see any money in the vault. It should actually be in Celo. We have shares that represent our value. And let's go look at what happened here. Staked Celo manager. Holy shit, it worked. Maybe it worked, right? Like, I don't know. It looks like we actually deposited. So now
ST Celo, you see?
Yeah. I think it worked. Let's try withdrawing. If the withdrawal works, then we know everything worked, right? Oh boy. Let's see if this works. Yes, it did. Okay. So we actually got the full like yield bearing asset to work. Yeah. So yeah, to summarize, we used scaffold ETH to tinker. We used Cursor and Claude as our wingman, and we built first a vault, and we made sure we could deposit and withdraw using that nice debug interface in scaffold ETH. Let me show that nice debug interface. We made sure deposit and withdraw worked fine. Then we built a cookie jar using an old contract of mine that lets you withdraw like 0.001. Then we spent like 30 minutes getting events to display because the EVM sucks sometimes. And then in the last like 5 minutes, we actually built the DeFi piece, and we put our deposits into the Celo manager, stake manager. And so now anyone can YOLO Celo into this contract using our front end that's deployed to IPFS. Let's re-yarn IPFS it. Let's see, new yarn IPFS, right? We need to yarn IPFS with the new contract, but someone can go to this front end, someone can put in Celo, it's going to automatically stake that Celo, and also someone can withdraw cookies from the cookie jar. So now we have this staked DeFi vault that also provides yield that lets someone withdraw from it from a cookie jar thing. Hearts. Thank you for having me. If you want to learn how to build this kind of stuff, go to scaffoldeth.io, go to Speedrun Ethereum and go build through these things. Thank you guys for having me. I got to jump on another call. Hearts.
Thank you, Austin, so much. Appreciate you. Appreciate your time. We'll definitely reach out to talk more.
Hell yeah. Awesome. Okay. I'm looking forward to more sessions. Thank you for having me. Hearts. See you guys later. Happy Wednesday. Have a good day. See you.
Well, shout out to Austin for that wonderful session. That was great. This will be the first of many, as you saw earlier in the message. So definitely stay tuned. You can expect hopefully people, Bertrand, me, myself, others in the Dev Guild will be hosting some of these sessions. So they should be pretty fun. And that's awesome. We'll probably get that code up on a repo somewhere so people could access and we could continue to build upon it. But yeah, shout out to everybody who joined the stream. Appreciate you guys. Let me do the poll one last time in case you didn't get it earlier. Let me go find the secret. Okay, where is it at? Oh, here it is. So go ahead and get that poll up if you can. It should still be open, I think.
I tried it and it worked.
Say that again?
I tried it and it works. So I have the proof. On-chain proof I participated.
Yeah, this helps with your Greenpill score, right? So, you know, helping with your regen reputation, showing that you're actively involved. So, you know, we build on chain, so definitely go ahead and claim these co-ops. But yeah, Bertrand, how was that for you? And then we could close the call.
Yeah, thank you for having me also. I mean, I feel it was a good experience. Like showing live Austin Griffith is a legend. So, and glad that Corey got this cookie jar ID and about yield. Like, it was impressive to see it yield working in only 5 minutes. So it shows that it doesn't have to take so much time always. And
Exactly, yeah.
like a cloud code. And what's your feedback about it?
Me or
Yeah, you?
for me? Yeah, for me, I think it was nice because the first part was really walking through the cookie jar architecture. So you're able to get a sense of course, it's like a different contract, but it's the same concept. So I think that was nice for people to see that. And then I think, you know, the end, definitely, we were able to get towards the yield side of things. And I think we could build upon that. And I think, of course, this is the first one, so kind of figuring out like a cadence of things, you know, will definitely, I think it'll just get better and better, ideally. You know, hopefully Austin has more bandwidth, but I think it's great to see Austin, you know, do it because he teaches a lot. He's one of my first, you know, when I joined this space, one of the first people I learned from. So it's being able to see how he goes through things, takes time, you know, and stuff. So like I think, yeah, very, very appreciated that. And yeah, it was nice.
Yeah, and we started from scratch. So even quitting all the cookie jar concept with the scaffold list. But I like it that he was showing the new scaffold list with QuitIs and with the cursor rules integrated. And the feedback I got before is that the cursor rule evolved so much that some project decided to not put them yet on GitHub in their Git repository to motivate the builder and like the people cloning the repository to run themselves the cursor rule generation.
Yeah. That's background noise.
There is a balance, I guess, to find between using the integrated rules and in generating the rules at the last time. Because depend, I guess, on your token budget also, like your LLM token budget. Let's say Austin is always refilling his token budget without any issue. I guess not everyone finds this expensive.
All right. Well, there was some background noise, but I think let's go ahead and we could close the stream. Hopefully everybody's got their PO out. Appreciate everybody joining. We'll see you for the next 5 minutes.
Yeah. All right.